Good evening, ladies and gentlemen. We warmly welcome all the participants who have joined via online to our IESL Water Forum webinar on role and responsibility of engineers in catchment management to supply safe drinking water, which is a timely topic because we are facing increasing water pollution these days compared to past. In order to enrich the event, we have brought two leading experts in this area to share their views, experience, and new developments with our participants. We hope the next 1 hour time will be very useful and memorable, which brings new insights to the participants. Without taking further time, I kindly invite Engineer Mrs. Batra Kamaldasa, Chairman of IESL Water Forum, to deliver the welcome note. Before that, there's a kind reminder, all the participants are kindly requested to mute their microphones during the session, and we will have question and answer session at the end. Any questions, please keep them posting in the chat box, which will be taken at the end of the session. Thank you.
Thank you, Sridharan. Good evening to all of you. I welcome all of you on behalf of the Water Forum of IESL to this webinar on role and responsibility of engineers in catchment management to supply safe drinking water. This is one of the events that Water Forum has planned in its annual work plan, and also an activity of a series of addressing catchment management issues in Sri Lanka. So I am grateful to the two resource persons, Engineer Asoka Jayaratna and Dr. S.K. Veragoda, for accepting our invitation and be with us today. I warmly welcome both of you, sirs. Then I welcome all those who have joined live through the Zoom link to listen and express the views. So I'm sure this webinar will be interesting and useful for all of you, and also for the Water Forum to carry over our future activities based on the recommendations and views expressed by both of you. With this warm welcome, I wish all a very fruitful evening during the today's session. So I'll hand over back to the organizing committee to continue the webinar. Thank you very much.
Thank you, Madam Engineer Batra Kamaladasa, for the wonderful welcome address. Now we will move on to the next agenda item, introduction of guests. We have two prominent professionals today to share their knowledge and thoughts. Engineer Asoka Jayaratna, he is joining for the this webinar from Melbourne, Australia. Engineer Asoka is the water quality specialist, senior management at Yarra Valley Water in Melbourne, Australia. He holds a BSc in Civil Engineering degree from University of Peradeniya, Sri Lanka, and a Master Engineering Honours in Water Management. He is a corporate member of the IESL and the Fellow of the Institute of Engineers, Australia. Engineer Asoka has been working in the water industry over 36 years. He has been with Yarra Valley Water since 1997. His main areas of expertise include development and implementation of drinking and recycled water risk management plans, implementation of hazard analysis and critical control point system for the drinking water supply system, development of strategies to improve water quality in the distribution system, routine water quality monitoring and maintenance programs such as water mains cleaning, reservoir cleaning, regulatory compliance, regulator and other stakeholders and special investigation. Engineer Asoka has been responsible for managing and implementing several innovative research projects. These include development of distribution system water quality modeling tools, with the Cooperative Research Center for the Water Quality and Treatment and Recycle Water Cross Connection Detection Device with the University of New South Wales. Engineer Asoka has been leading several innovative research projects at Yarra Valley Water, including CF modeling of storage reservoirs to model water age, patent heightened insertion device for installation of real-time monitoring equipment and water age modeling. Engineer Asoka has published papers in international journals and presented at several international conferences, including the annual Water Conference in Australia. In addition to the full-time role at Yarra Valley Water, Engineer Asoka has been assisting the World Health Organization as a consultant water safety plan expert since 2009. His contribution to water safety plan activities include presentation at Stockholm Water Week, WHO IWO conference in Malaysia and the Philippines, authoring the viewing several water safety plan guidelines document and publications, water safety plan training and auditing in Philippines, Vietnam, India, Indonesia, Thailand, and Sri Lanka, and providing guidance to the developed water safety plan regulatory frameworks in Malaysia and Maldives. Hereby welcome Engineer Asoka Jayaratna for this event. Thank you.
Our second guest is none other than Dr. Veragoda. He is joining from Kandy for this webinar. Dr. S.K. Veragoda has specialized in water and wastewater treatment, currently serving as a project director of China-Sri Lanka Research Grant Project attached to Ministry of Water Supply, Sri Lanka. Further, he leads team attached to the Water Safety Plan Advisory Unit in National Water Supply and Drainage Board. In addition, he has been recognized as an expert on applications of water safety plan and international auditor in the region by WHO. Dr. Veragoda has obtained his basic degree in civil engineering in 2001 from University of Peradeniya and master's engineering degree on water and wastewater treatment in year 2005 from Asian Institute of Technology, Thailand. Then he has read his PhD from Saitama University, Japan, and obtained his PhD in year 2009, specializing in wastewater treatment. Dr. Veragoda is a chartered engineer. He has involved in water treatment plant design, construction, and operation for 20 years. He has served as a chief design and process engineer of Greater Dambulla Water Treatment Plant of 32 megaliters per day capacity. Further, he has designed several medium-scale water and wastewater treatment facilities in the country. He also serves as a visiting lecturer in many national universities, such as University of Peradeniya, University of Rajaratnam, University of Uvavelas. His research collaboration expands over Japan, China, Singapore, South Korea, India, Thailand, United Kingdom, Australia, and many other countries. He has already contributed for over 60 research publications. In addition, he has supervised more than 10 postgraduate students attached to local and foreign universities. The government of People's Republic of China has awarded a grant of renminbi 81 million to government of Sri Lanka, referring to his request and recognizing his contribution towards water research in Sri Lanka. Further, he himself, as a member of research teams, has received several research grants from various agencies to continue his research on the groundwater pollution and appropriate treatment. We cordially invite Dr. Veragoda for this event. This webinar event will be moderated by Engineer Rajkumar, who is an additional General Manager of National Water Supply and Drainage Board, Chairperson of Domestic Industrial Water Subcommittee of Water Forum, and Executive Committee Member of Water Forum. Engineer Rajkumar, virtual floor is yours.
Thank you, Sri. The The topic today is role and responsibility of engineers in catchment management to supply safe and safe drinking water. So the key words are catchment. Catchment is an area where water is collected by natural landscape. An engineer, our contribution is to the society directly or indirectly in the land area of the catchment. When pure water is spoken, our imagination is the water that is shown on the left hand, where you see it's in the terrain. It looks very clear and nice. But when we think of drinking water, we are looking at a clear water in the glass where there is no particles or anything that are in suspension. These are perceptions of us. The water engineers being involved in the water look for clean, undisturbed water. As an engineer for development works, our intervention in the catchment will have impact on water quality. Surely, the media and the public in general have been raising concerns. Recently, you may all will remember when there was an oil spill in the Kalani River. That was a major issue closer to one of the water treatment plants. If everyone like the water engineer shows concerns about the consequences of the activity in the land area of the catchment, the impact on water quality in the river could be minimum. WHO, World Health Organization, is looking for better hygiene to reduce loss of productive time lost due to health reasons. Sri Lanka, when you look at the right-hand map, where it shows Sri Lanka has about 103 rivers, and all these lands have a catchment area. Any activity has some contribution to one of the river catchments. Pipe-borne water is one of the direct user of the water in the catchment with purification and satisfy the water quality standard. There are other users who do intermediate test, or even they do not do any test, but they believe that water quality is good for consumption. Pipe-borne water is expensive. It is brought to us at the required pressure at the required location. It costs about 48 rupees per cubic meter. When you look at the sources of water, what people are using, we have protected wells, which is representing about 36%. And then we have tube wells and rainwater, which is quite a small percentage as such. When you look at these, the graph on the picture on the right-hand side is talking about the river catchment in Kalani Ganga, which was when you look at it on the right hand, the extreme right, it's green in color, which is implying the water quality has been quite good at the upstream. But more and more it comes closer to the downstream, it's indicating red color, or it's saying it's poor quality. To remove the impurities, chemicals are being used in the treatment process. So if you look at the graph on the right-hand side, it shows that how the cost of chemicals have increased over a period of 10 years, which is about 50%. The question that rises in the mind is why we deteriorate the water, and can we keep it clean as such? Now, as engineers, if we are mindful about the water quality deterioration due to development activities, that would have been the first step. Water what we get from the groundwater, only disinfection is necessary, required, not in all cases, in some cases. There are instances in the same river, purification cost is high in one location, and then again, in another location is cheaper. So in order to import, the chemicals are not produced in Sri Lanka. It's actually, we have to import it. And then, you know, that at the moment we have the foreign exchange concerns, the dollars is issue. And also, you know, that even the freight charges have gone up. This has a greater impact on greater impact. So I think we should look forward how we can reduce the use of imported and the chemical usage as such. When we look at the webinar focus, we are looking at the challenges in preventing further deterioration due to continuation of unplanned urbanization, impact of climate change, how to understand and manage the already developed watershed, importance of vulnerability assessment in the context of climate change, and importance of moving towards best practices to manage watershed. So I think I have a probing question to Asoka. According to the latest WHO and UN reports, the Sustainable Development Goal, half of the world's largest cities experience water scarcity. And in the world, 500 largest cities estimate that one in four are in a situation of water stress. More importantly, by 2030, 1.6 billion people will still lack safe drinking water at home. As a water expert having vast experience in water sector, 1, why watershed is important as source of drinking water supply? 2, how the increasing trend in rapid urbanization and increased urban population poses challenges to safe drinking water. Asoka, it's up for you to
Thank you, Mr.
respond.
Rajkumar. First of all, warm welcome to all of you from Melbourne this evening to have a bit of a discussion about this important aspect of catchment and drinking water. And also I would like to thank the Water Forum for inviting me to share some insights on this topic. And before I answer those two questions from Mr. Rajkumar, I would like you to, our participants, to put a couple of questions to our participants. I want you to think about this and keep thinking throughout the session, but not only that, even after our webinar. So my first question to you is, as we all know, water is important. We can't live without water. Water is life. But keeping that in mind, as engineers, have you ever thought, well, from where do we get this precious commodity when you drink that water from a tap, or you give it to your loved ones? Have you ever thought about that? More importantly, have you ever thought about the role that you would be playing in your day-to-day activities in protecting the catchment? So keep those questions in the back of your minds and try to answer those, and hopefully will help you to even untangle some of the important issues. So talking to engineers, I'm sure you all understand asset management, right? And some of you are water engineers, some of you, I believe, could be civil engineers doing construction, roadworks, buildings, big development projects, and you know your assets have to be managed. But important thing is, a concept is that catchment should also be treated as an asset. More you develop or more you disturb the catchment, it's not rocket science that you will have less water available. So you are as engineers, we are in a catch-22 situation. Should we develop the within the catchment, or should we not develop? So what can we do? Well, the catchments, if it's already developed, you need to, like managing your assets, you need to manage the catchment to make sure that the impact that we cause by doing things in the catchment do not deteriorate the catchment. Uncontrolled urbanization. Now, I was thinking about this topic, and I found this picture in the internet, and this is the where I come from, Kandy. My hometown is Kandy. As a young engineer, I was asked to do a feasibility study with a colleague of mine to build a road to the Hantana telecommunication tower. The tower wasn't there at the time, but at the time, did I think about the impact of building a road in the Hantana range on the Mahaweli catchment? I don't think so. I wasn't aware of it. Now, this is a picture from a fancy hotel near Katugastora. I'm sure the view is nice, but whoever approved the building permits, or gave permit to build this, did they ever think of the impact of this building, the wastewater systems, as going to the impact on the intake to one of the Kandy water supply systems? The intake is not far from, the what you see in the picture. Similarly, I'm sure there are chemical engineers who manage or own or operate factories, chemical factories, and manufacturing, etc. Have you ever thought what to do with your discharges from your factory? Did you just, it's the last thing you probably think. So it is important, keep this in your mind. This is one of my favorite ones. Apologies for bringing a lot of pictures related to Kandy. That's closer to my heart. And this is the brand new, almost brand new wastewater treatment plant in Kandy. Now, the engineers who designed this wonderful structure, did they ever think that when one day there's an incident and sewage started spilling into the Mahaweli River, what would you do, or what would you do to prevent that sewage getting into the drinking water intake, which is literally a kilometer downstream? So I hope I have given you some ideas here on the importance of engineers thinking outside the box. So once catchments developed, what does it do to the quality of water? Or I don't like to use the word quality. I always use the word safety. Quality is like it's not the right terms. It's just to save what you do to save water. Obviously, if there are no human settlements, you won't have any of those nasty pathogens you see in here, viruses, protozoans, and bacteria. I'm sure non-microbiologist engineers now understand a bit more about pathogens with the COVID pandemic going around the world at the moment. But also, you can't forget the impact of chemicals, long-term impact on human health from chemicals. So it is inevitable that if you develop catchments, these nasties will be, unfortunately, at your intake to the water treatment plant. So what can we do? The catchments developed, or we can't stop development. If you can, that will be ideal, but you have to live with what you have got. So it is important to minimize or prevent the contamination of your catchment. Prevention at the earliest point of any process is the best approach, right? When you're dealing with catchment to consumer, so the water starts from the catchment, ends up in your kitchen tap. And some people might think it's okay to pollute as much as you like, and then you can just have that treated at the treatment plant. Unfortunately, it doesn't work like that. The best example I can give you, rather than being too technical, is it is, to me, and the analogy is, if I keep eating unhealthy, fatty food and a lot of sugary stuff and not worry about my health, I can take tablets, you know what's going to happen, right? So that's not prevention. So the same rules, I guess, principles apply to drinking water treatment.
Thank you, Asoka, for that quite a detailed explanation. But I think you brought some ownership by saying catchment as an asset. I think the moment you give that thought, the whole thinking of the personal thinking changes. We depart from water engineers to all the whole engineering community as such. Then again, you came out with mind-provoking questions, especially on what will happen to the wastewater consequent to a development and what's going to happen. Further, also you emphasize much more about the chemicals and the effects thereafter. I think those are very valuable questions that have been posted upon, and I think that's a message we could take it further for in future consideration. I think I have another question to Dr. Veeragoda. Dr. Veeragoda, as such, being a tropical and water-rich island in the Indian Ocean, historically, with 2,000 million annual average rainfall, and also we are having roughly 130 billion cubic meters of water through rainfall. How the climate change impact due to impact causes unprecedented change to the Sri Lankan water sector? Dr. Veeragoda, over to you, please.
Thank you, Mr. Rajkumar. So good evening, everyone. And it's an honor for me to join here together with Mr. Asoka Jayaratna from Yara Valley, one of the founder member in putting up watershed plants in the country. And thank you, ISL, for inviting me for this particular, a very interesting sort of timed important webinar. So it's a very interesting question for someone to post here, because I mean, we are living in a tropical country, and almost like all the wet zone is very much blessed with 2 monsoons and another 2 intermediate monsoons. But when you get the real picture, so that is something alarming, and we are at a very sort of strategic point. So as the team said today, so it's something not that we as water engineers can come and play a significant role in water catchment, is that we have to get together. So we have to speak, we have to have a common platform. So let me start with the one of the golden era of the King Ravana. So that's almost 3000 just in 3000 BC. So Sri Lanka has been divided into 10 different divisions. That where that you can see the divisions are coming based on the river basins. So it's not like now currently we got the administrative basins, which is not going exactly with the water flow, so water management. So that is something that we have to think of. So if we can get back to this history, because we had a very much luxurious life and sort of things, a lot of developments we heard about this all, and this is what it was there. So this is something that we have to think of, because when even NASA looking for some alien creatures living in any other world, so they are going and searching first for the water. The existence of water will get a lot of stories to us. That is what it says. So whenever you take the whole story here, so what I want is, we have to think of the water availability first. So the question asks, we have 103 river basins, and out of that, still 18 are perennial. So that means we got water, and we got a lot of tanks around us, and this coming with a very long history, and we were very much known for this water management and all. And then out of this, there are 80 is coming as medium scale, or we could call as major large reservoirs. But the question, even though we are getting 2000 millimeter of annual rainfall in a land of 65,000 square kilometer, and we got almost like 4% of the land area is covered by water bodies. The question, do we have enough water? So the question again back, in other words, what Mr. Rajkumar asked me, is that a shortage or is that a wastage? So I'm really wondering, so if you take the whole world scenario, if you take all the water volume in world into one basin, you have simply a 1 spoon of water which which can be directly consumed by human beings. If it is something else other than that, the surface water bodies and whatever the groundwater bodies, other need a lot of treatment, other needs a lot of other involvement, science and technology involvement. So that is what we find. So when you take up the water availability and the water shortage, the question is that, I mean, how much that is being passed to the ocean without having a usage. So that is a question someone would raise here. So then we would have something alarming, that because if you take one like Kallan River or Ginganga or anything like Kaluganga, so where that even the Mahaveli River, so they get almost like 50% of water being back into the ocean without having proper usage. So that's the question would ask. If I take this in other words, if I take this into the financial figures, what I see in last decades itself, we in only due to the agricultural loss, we had almost $1 billion lost. That's huge money. So if you could convert that loss into sort of useful structure, use of civil activities, I mean like a hardware activities, so that might help us to save this water. So that is what I want to emphasize here. So this climate change, as well as this all whatever happening around us, has made a lot of challenges, so that we have to think of that. So then, I mean, when you are getting to the water availability, so especially we have to think of the climate change. So climate change is something that we have to think here. So one would ask whether the climate change is happening. Yeah, that's a question for someone to ask, because still researchers might get confused, because around 10% of the total people, the researchers will come in whole world around, so they might still question whether something happening is cycling, it's a cycle process, or is there something coming as strange to us. So the very real, I mean, the real data, whatever it's getting to us, if you go and see these mean values coming from the long-term averages and all, and you find it's a greater variability is fine over there, and extreme events are coming. So not like the past, you got pack rainfalls with very high rain intensity. So our drainage systems might not be able to take up this all. Our hydrograph has been skewed, and we are having a big challenge of storing water, because as we discussed previously, we find most of the water is being passed to the ocean without having proper use. So that will be getting me some good idea here when I think of the climate change. So the climate change has been impacted heavily on water. So the researchers, the scientists, whenever they talk about climate change, they do not go into the lithosphere or atmosphere. They are just getting with the hydrosphere. That means they find a very strong correlation between climate change and water. What has happened? The process in water cycle has been activated, has been accelerated by having this all different scenarios what we right now face out. So when I get to the climate change again back, you would observe that it's impacting on many other factors like the temperature, then precipitation, as well as the drought is coming. That's again back connected with the rainfall. This all scenarios happening. So this is what we observe, and it's making a huge variability, a serious uncertainty. So it's not like past we could have done our planning for like 30 years of period, but when you take the climate change impact, you find that it's not realistic, it's not practical. We as engineers, we are not in a position to justify our investment. That because here huge uncertainties come in here. So we have to think of, so if I just get back to the question what Mr. Rajkumar asked me, that's definitely climate change is heavily impacting our water resources. Whatever we do experience right now won't be the scenario, won't be the system we will find in another 10 years time, Mr. Rajkumar.
Thank you, Dr. Beruguna. I think good that you spoke a little bit of historical water usage pattern. But again, you posted a very good question regarding whether it is shortage or wastage. Even though you saw that there is a lot of water being sent to the river, sent to the sea, but you clearly explained that the climate change and the packed rainfall is one of the main contributing factor, which gives us a rethought of going in for another alternative option of trying to manage the situation. So to again, Dr. Veeragoda, I have another question to post on to you. Change in global climate could adversely impact on the on water quality and quantity, but reliable forecasting of this impact on specific water bodies is hardly possible for the near future. In this scenario, how the climate change and the aggravates effects causing alarming situation to water resource in Sri Lanka? Dr. Veeragoda.
Yes, Mr. Rajkumar, again back, that's very interesting question, because we as engineers, we do understand what is modeling, what is forecasting. If we just remember, if you just recall back the World Cup, the last World Cup had in UK. So if you, I mean, like if you just thought of that, I mean, how many matches have been cancelled because of wrong weather forecast? So that means country like UK, sitting in Europe, having surrounded by many of the countries, many of the grid stations, whatever coming under this meteorological grid system, but still they could not predict the climate change with a certain accuracy. So this is why we call it as a forecasting. So if you just take the modeling, so we found IPCC, that is the responsible body in the world for this research. And if you just go with the modeling, whatever you find, they find different options. So if it is happening this way based on the current scenarios, they are predicting in various under various conditions. So all the way, there's a huge uncertainty. And another question that the scientists are focusing here, that is because whatever your forecasts are based on the existing technologies. So in another 10 years time, what would be the technology to address this all the energy consuming activities? There could be some innovative approaches come in. So this model are not being used or modified to address the future scenarios. It's done only based on the past records. That's a question. So we have a lot of uncertainties coming here. That is the question. That is what we do understand. So whenever it's coming the whole this story, so you find that the climate change, how it is impacting on water. That is something that we would ask. So if I just thought of this, I would like to put up into 4 layers. The very first thing, that whatever the direct experience you find here is just increase in temperature or change in the precipitation. You might observe something coming as up in sea level. So that is what you find. But the second level, third level, fourth level is something very much alarming. So if you just get the fourth level, it might be impacting heavily on migration. It might be impacting on unemployment and terrible negative impact coming on the economic, as I said. So simply right now, if we just invest $1 in water sector, you might be having a return of $4 back in the economical analysis. But in future, it might be seriously out. It could be about $10 you have to invest to get a economical benefit of $1. That is would be the reverse way. So that is something that we have to think of. So this is all the way connected this climate change. So if I just take the direct adverse impacts coming on water, especially in drinking water, as well as other water, all water activities, there are a lot of stories coming here and there in the world right now. You find the water scarcity. You find that a lot of chemical being leaching back into our water. During the long dry spells, the main sources might be the waste discharges coming into our water bodies, as well as due to the excess use of agriculture. And once after lowering down our water level in reservoirs, all sink phosphorus might be coming back into the water bodies, that because of the aerobic conditions, then the algal bloom will come up. Then people might be directly exposed into the unsafe water. So then one other side, our headworks, if you just see the bottom left hand, the photograph which shows us inside of a pipeline, it might be getting corroded, as well as even after having a lot of unorganized urbanization or anything like in development in our catchment, this brings a lot of suspended solid into our water bodies. Usually the conventional water treatment plant are designed to accommodate maximum 1000 NTU. That's the unit that we are talking about, the suspended solid. So this all bring a lot of challenges. Finally, in elevated temperatures with accelerated chemical reactions, what will happen? we will have a really alarming situation. So 2015, UN has declared that every citizen in world having equal right to have access to safe drinking water. That's a basic human right. So we as a nation, we are responsible to ensure that the whole population. That's a question. So someone would ask. So Mr. Rajkumar, if I just summarize, uncertainty making a lot of challenges, and prediction is not that easy like past. You can't just rely on previous records. So what the experts telling us, we can plan for 30 years, but the improvement, development might be planning only for short term in 5 years. Otherwise, you might not be able to justify your investment in under the climate change scenario.
Thank you, Dr. Veeragoda. I think it was quite a detailed one and quite fearing one also. Where I think first you had your 4 layers, which was very clearly shown. I think we are in the first layer. And I presume that if we can control it somewhere in that level, it'll be an ideal situation. I think that's what we are here today, trying to address this scenario. And also the water quality deterioration due to unavailability of water is quite fearing. I think I have another question to post on to Asoka. Acknowledging the fact that rapid population growth and urbanization inevitably poses huge challenge to water sector in Sri Lanka. How can we learn from the best practices from the others to better manage and protect our water catchments? Asoka, so over to you, please.
Thank you, Mr. Rajkumar, for that question. So what is best practice? You can always learn from best practice. One of the examples, what you see here is it's the catchment that supplies drinking water to about 4 million people in Melbourne. And fortunately, our catchments are fully protected, which means, as you can see from the picture, one of our reservoirs, you cannot see a road. There are no roads. There are no people, no human development. And the catchment is fully fenced off. Therefore, the catchments we call fully protected. Now, unfortunately, there's only 4 of such systems left in Melbourne, in the world, and Melbourne is, as I said, one of them. Now, what's the benefit of having this best practice? If you could go back and change reverse everything we did, and the numbers on the screen speaks itself on the benefits, right? So in Melbourne, we don't have a filtration system. Majority of our system, about 80%. We only add a bit of chlorine. It saves huge capital expenses and operational expenditure. And Mr. Rajkumar mentioned at the beginning and a few times about the chemicals. We need less chemicals. So in the end, that means as a customer of Melbourne's water supply, I pay much less for my water. So it benefits the healthy living style of people who live in it. Unfortunately, the reality is a lot of catchments I have seen from the Philippines all the way to Maldives. Unfortunately, they are already fully or partially developed. That means there's multiple users. If you take the case of Sri Lanka, the electricity board and the Mahavali authority, they manage your dams and hydropower systems. There's irrigation department who take water, and then there's domestic and users and industries. When you have human settlements, it's inevitable. You either have a sewerage system or a septic system that brings a huge risk of contaminants getting into the drinking water sources into the catchment. Agriculture and farming brings another dimension to this added risks. Then the infrastructure. So if you look at all these dot points, engineers are involved in pretty much each one of those activities. So that's why I posed that question to you at the beginning. So what can we do? Unfortunately, as I said, you have to live with the catchment we have currently. So the World Health Organization, who are the health experts, in their they have recommended an approach to understand the status of the catchment. When I say understand, it's proper assessment of the catchment. There are certain techniques we can use. Surveys called sanitary surveys, sanitary inspections, using various techniques, and also water quality data. I'm not talking about taking a sample today and the next sample a month later. You don't know what happens in between. So you need to be a bit smarter, especially Dr. Veeragoda mentioned, climate change. When there are droughts and floods, water quality changes significantly. So you need to have a good understanding of those two, and you can make an assessment of your catchment. And a tool which we will sort of touch base a bit later as well to do that is the water safety plan to manage systematically manage your risk from catchment to consumer. So why do we do this? It helped us to identify the adequacy of controls. Do we have controls now in place to minimize, prevent contamination, or are there gaps? And if so, then to help you to implement new controls. Again, prevention is better than cure. So the world best practice, WHO has defined what we call health-based targets. That means water that we drink has to meet certain requirements, and they are defined as health-based targets. To achieve those health-based targets, we need to introduce controls at the earliest point of the process. If you take drinking water as a production line, the earliest. The first process step is your catchment. So introducing catchment controls. I'm not going to go into any of the details. There are tools available and recommended by WHO to understand your catchment, to help you to manage the catchment. And obviously introduce process improvements.
Thanks, Asoka. I think that was quite a clear explanation. Well, I think one of the main messages what we are given is that catchment control is the most economical approach where mitigation is taken at the source. I think that's the best message what you could do as such. I think even under the water safety plan, I think you all also mainly focus in that area. Dr. Veeragoda, given the climate change is the main contributor to negatively impact on quantity and quality of source water, what lessons can we learn from global approach to minimize the damages? Dr.
Yes,
Veeragoda.
Mr. Rajkumar. Yeah. So that's again back sort of interesting question for someone to think of, and especially engineers like ourselves, we should take this all, and especially we have to keep in mind that don't reinvent the wheel. So there are a lot of technologies. So I would take here the one that coming something as a nice solution coming from nature. So this is one glacier coming in Argentina. So the wonderful thing is happening here. The melting rate is almost same as the fixing rate. So in net, there's no impact over the volume of the ice is being trapped in the glacier. So that is what we can think of. So when you take up a lot of examples, experience from the world, you find there are a lot of developments coming, like in the policy level developments, as well as in the ground level developments. The one very well known country for whole world as coming with what is scarcity, like a country like Israel. So they have got 5 strategies to put up in their all activities, all actions coming in their development. So not only water, but all other scenarios, all other segments, they have to think of this. They have to give priority. So Singapore is another wonderful sort of story. So the 4-tap concept. So they have been taken out this all into consideration, and especially Singapore is well managing their water cycle. It's not like just letting water to just pass in nature, under nature. It's like they manage in that well. So those are the nice concepts that we can think of. So whenever it's coming to the planning, and again back, as Mr. Ashoka said very clearly, WHO is so keen to introduce this climate resilient water safety plans. That's really helping us to plan. So country like Sri Lanka, why do we get that much of terrible impact coming from climate change? So when you take up the past records, in 2018, Sri Lanka has been ranked as the second mostly affected coming from country from climate change in the world. So 19 is taken into 6th position, but still we are terribly impacted. So we experience every day. So that is because the preparedness is the problem. So climate change help us to think in different angles and bring all the professionals come into one single umbrella and work together. So IWRM, integrated water resource management, probably would be another option for us to think of. So not only that, we might find some other interventions coming, like this is you from USA. So climate change is again back connected with the fossil fuel. So they are moving towards this green energies and thinking of having desalination. So desalination is really expensive sort of solution. If any, it's coming that because of the energy consumption. You take in average 1 cubic meter might cost around 1.5 US dollars. But in Sri Lankan context, still we are going with the conventional water treatment is about 30 cents of US dollars. That's equally huge, and it's terribly huge for us. And we are not in a position to afford for such a serious sort of financial intervention. So we have to think in other way, like, so there are a lot of areas where people living with a lot of hardships, but still they manage to live. That because they get a lot of innovation. So this is another option where you can think of having fog harvesting. So they got water for 400 families, 400 people living over there. So that's one good example for us to think of having this. Not only that, simple technologies like coming from Ethiopia. So this is a nice shelter where that they can get the protection as well as they can collect water. This is something again back a simple story done in 2017 in Ethiopia. So this is what we have to think of, and we can get the use of these all options. And again back, one simple idea coming from Nepal. So they're just having temporary storages, and later during the rain period, they're just making them to use to recharge the groundwater. So that's a one very good sort of step as we individuals can do. So this is another wonderful story coming from UK, especially they call them as sustainable drainage systems or Suds. So this is that where that they are going with a lot of greeneries in landscaping, as well as they are keeping as much as possible surfaces for percolation. So that is all the way that they are thinking of. This is what that we can just bring up from whole world, coming from developed countries and developing countries, regional and the whole across the world. So that's what we have to think of. So we as planners, when you are going with developments, we have to think of the adverse impacts coming, and which has been taken, which has to be taken under the climate change scenario. So we as a country, still we find some improper planning, especially the urbanization and the story has been gone out. Yes. Yes,
Thank
Mr.
you.
Rajkumar.
Yeah, thank you, Dr. Veeragoda. I think that was quite, you emphasized on innovation and especially on fog harvesting. That's why I think it's something where we also can think in Sri Lanka as such. And also, I think groundwater storage is not something new to us. I think we had been practicing it for quite some time. I think those options still could be revived back, and then we could see how we could move forward as such. Then, Dr. Veeragoda, I think I have another question to post on to you. With the lessons learned globally, how the Sri Lankan water professionals, engineers, urban planners could promote climate resilience among government, policymakers, donor agencies in water sector? Will such paradigm shift will contribute to protecting our water resources?
Yes,
Dr.
Mr.
Veeragoda.
Rajkumar. So yeah, so that's the question that come in as our responsibility as engineers, planners, and all. So when you take up the Sri Lankan preparation, we got the climate policy done by the government of Sri Lanka. So we got a very clear vision for us. So a future where climate change will have no adverse consequences on Sri Lanka. So that is something that we have to take in all our planning activities. If you count this in our planning, as I said, so the long-term planning as well as short-term planning might help us to address and get ourselves prepared for the climate change. If I just think about the other activities like whatever is coming from the Department of Meteorology, so that's again back they are putting a very useful information every day. So you got daily forecast, you got weekly forecast, as well as you got monthly forecasting. So this get us something, some preparedness for us, some alarming. So why not using this in our all day-to-day activities? So when you are planning anything like that, when you are planning your operation and maintenance activities, you can think of using this all whatever useful information. In addition to that, the vulnerability assessment done by the Department of Disaster Management. So that's again back. They got the flood hazard zones, they got the drought hazard zone. So these are something that we can take into our consideration. So that's also very useful information. So in addition, there are a lot of other involvement activities going around the country. So bringing back our cascade systems, which was something recognized by the whole world for better water management. So that's also another option that we can think of. So whenever you can save water, store water, you can go with the surface water storage. If not, we got some other options. So we have done a small scale piloting project in Kartagas Digili, where that we got 6 cubic meter storage. This is a sort of adaptation of technology from China. That's called Sponsity. This done in Europe, this done in country like Maldives. They got 12,000 cubic meter of storage in Maldives, one of the islands, under the concept of Sponsity. So keep in mind all the way, the city planners can find the enough precipitation, enough percolation, enough storage. It could be temporary storage. So we have to keep in mind that adaptation coming with 5 different steps: anticipation, responding, coping up, recovery, and adaptation. So that is that we have to take into consideration. So you have to anticipate. So modeling will come here. You have to find the past records. You have to see the correct forecasting. You have to talk to the engineers, and you have to try it up. So this is what that we want to make it happen. So we want to get the correlation. We need to bring all the different sectors together for this adaptation. So that is why, because climate adaptation planning, not just for water, it's coming for different vulnerable sectors. Like we found here, there are 9 sectors and is all interrelated. So that is what biodiversity, tourism, this all connecting with the economy. So that's making a huge impact over. So when you take up the disaster preparedness, that is putting up here under the climate change. So we have to come up with 6 different typologies. So that is where the diversification of water supply, groundwater recharge, as I said. So these all activities come in and play in a big role. Not only that, we have to think of some more researchers, some more investigation. Country like Korea, they are testing almost like 106 parameters under their regular water quality testing. So we need to have a facility for this. So we thought of having under the Ministry of Water Supply, they have planted a advanced facility, probably the best in the South Asia, to test your water quality. This is in front of engineering faculty. So testing as well as investigation probably will be helping us to make sure the potential pollutants as well as the capacity in terms of quantity. So this all bring us a lot of feedback, and we might be able to reach to the goal of government of Sri Lanka by 2025, where that we are focusing of 75% by borne water coverage. So that is what we have to think. That will not happen alone. We have to bring all the sectors, all the different parties to come and plan our the water management.
Thank you, Dr. Veeragoda. I think you have quite well explained, also made us to think about our historical method of capturing water, the build back the cascade system. I think is something which we had been processing, and I think that might be one of the things to be revived for us. Especially, we know that we have ample water, so the groundwater recharge is another area where you had been talking of. Also on the stormwater control and capture, that's again another area we could think of. And the other foreign thinking of the spongicity, I think we had been talking of that, and now you have shown that how it could be implemented in other countries as such. So Ashoka, I think I'd like to pose the last question on to you. As a water sector expert, how do you see on the role of an engineer to protect and precious watershed that is the backbone of safe and reliable water supply system? Ashoka, after you.
Thanks, Rajkumar. I think that's probably the most important questions to this audience. So what options do you have? Keep in mind the questions I posed to you at the beginning. You can do nothing and wash your hands and say that's not my problem, that's the water board's problem or irrigation department's problem, and move away from it. I don't think any of the engineers who follows engineering ethics would do that. So what other options do we have? Think outside the box, move away from your comfort zone, and ask the question again, the question that I raised at the beginning: would you give this water to your loved ones, babies, elderly, by knowingly that not doing anything to protect the catchment during your day-to-day activities? So it is important, engineers who have some impact on from their professional activities, to work collaboratively with the water supplier as a key stakeholder. Now, stakeholder is a term that gets bashed around a lot. In this context, stakeholder means someone, an organization or an individual whose action will impact the water quality and quantity, and they automatically become stakeholders in this whole, part of catchment to consumer water supply. And this is a hard thing, I guess. I'm responsible for everything I do at work. So if I stuff up, I don't deserve to work, do my job. So, taking accountability and responsibility is I think, critical in anything. It's not just water. It is critical. So, these days we hear a lot about bubbles, with the COVID outbreaks, importance of not breaching the bubble. You know what happened to the cricketers and people who escaped from the bubble. I see protecting catchment as a bubble. Water supply at the top. In this case, but in most cases, it will be, especially urban systems, it will be the National Water Supply and Drainage Board in Sri Lanka. You're fortunate to have one system than many, one water authority than and too many unlike in other places. But they can't just do this on their own. They don't own the catchment in most cases. They don't they don't manage the catchment. We need all these stakeholders you see in this in this bubble, whether you are the engineers from the electricity board, provincial authorities who build roads and infrastructure, irrigation department, whether you be building infrastructure to supply irrigation water. So while doing that, you always need to think: Am I deteriorated in the catchment? Roads we talked about previously. We building a road, basically you change the landscape, you change the drainage patterns, etc. Factories and industries bring huge risks to drinking water catchments and drinking water as a whole. And of course, you can do things at the planning stage. Urban planners, when you plan projects, do that. So so we so hopefully we've given you some insights to made you think differently. So the World Health Organization, we briefly mentioned the water safety plans. It's the recommended approach to ensure, and it is the most effective way to ensure you manage the risks to drinking water following a systematic proactive risk management process from catchment to consumer. So you can see the word catchment is very clearly defined there, and there are processes in between, but catchment is where you start. And the tool we use around the world, including Sri Lanka. Sri Lanka has done really well in implementing water safety plans or trying to, be proactive in implementing water safety plans. So that is one of the vehicles we use to ensure the water is safe, but you can't just decouple the catchments from the discussion. And this is an extract from the WHO guidelines. I don't expect you to read the whole thing, but the word stakeholder I mentioned before, we can't really do without the input from all the stakeholders. I think, I want to stress that to you, because most of you, I'm sure, would be now thinking, yes, I do have something to do about the catchment with my day job. Therefore, I need to be a participant or a stakeholder in trying to manage the risks in the catchment. So, that's, I guess, Mr. Rajkumar, I think wraps up, sort of lively discussion, I guess, on the catchment and the issues or challenges we face today.
Thank you, Asoka. I think that was quite well explained. And I think finally we came to a point where we said that all of us have joined hands together to look after, to make a change. Drinking water is essential to all engineers, public, and everybody. Therefore, we have to work collaboratively to minimize the water quality deterioration in the catchment. And also the main message is that the catchment is an asset. So I think all of us, once you consider this as an asset, we will have a better value proposition. And coming to the Q&A, there were a couple of questions that have come on the chat box. Apart from that, if there is anybody who wish to make a verbal question, please raise your hand. We'll see how we could accommodate you. Dr. Veragoda, I think there's one question being posted to you. Where shortage of water, any plan for rainwater collection, any consideration at large scale? Dr. Veragoda.
Yes, Mr. Rajkumar. Yeah, that's one interesting question. Yeah, of course. I mean, so I would take one good example coming from our neighboring country, India. So they have done a very interesting work by making a sort of policy requirement and sort of regulatory requirement to make sure this rainwater harvesting within their premises itself. So they are taking the excessive water and they are making it to recharge their groundwater. Then brought a lot of good results in last couple of years in Chennai. So that is something that we have to think of. So the country level, we have adopted this in the Western province as far as I know. They have made it as a regulatory requirement whenever they are planning, approving their domestic developments, they are getting as one of the mandatory requirement to put up this rainwater harvesting systems. So that is one that we can think of. And in addition to that, we find another development program called Project, if I find it. So they are that they got 6 districts in the country under the dry zone, and they have done a lot of intervention for putting up irrigation system, recovering back these cascade systems, and making sure to store enough water, as well as they are having developed climate resilient water set plan activities also in those focus in this part of the country. So I mean, like, so when you are planning, definitely we have to think of this. So adaptation and preparedness is something so serious for us. So in the policy level, we have a lot of things to do. So ensure the mainstreaming of climate change into our whole planning. That's something I feel like is a bit lacking. So if you can make that actions, Mr. Rajkumar, that probably will help us to bring us good results in future.
Thank you, Dr. Veeragoda. I think there's another question also, your interest area of climate change. Climate change is emerging. In that instance, how we can increase the accuracy of planning? To Dr. Veeragoda again.
Yeah, that's really sort of very, I mean, like a strategic point that we have to think of. And really, I mean, like it's a challenge right now. The whole world planners are looking towards. I mean, so when you take up, so I had a chance to talk to the experts coming from many developed countries like UK and all. So what they are suggesting, especially the experts coming from International Water Association, that's IWA. So we can't just plan for 30-40 years because of the serious uncertainty, so that predictions might not be reliant, and there might you can't just go and predict for 30 years with this change in situation. So that's something that is really questionable. So what the suggestion, what the experts would come up with here, like they asked us to go for the macro planning for 30 years maybe, but you must have to have intermittent steps like in 5 years development plan. So you may invest for the short-term development plans, but while having a long-term development plan in your hand, that is the best option that we can try upon. And we get a very nice example coming in watershed plan. So when you are putting up this climate resilient watershed plan, it's just for water, but for all other planning activities, we can think of how the existing current scenarios, and on top of that you can think of how the climate change will impact on this planning. So there could be something coming as positive and there could be something coming as negative. So this particular analysis might help us to think of the existing scenario together with the climate change, the climate change impact. So that's something that we have to think of. So planning is something very serious. It's really questionable because of the uncertainty whatever right now we are facing. So Mr. Rajkumar, probably I have answered that question.
Very good. I think this groundwater recharge was quite interesting. And then again, there's a question being raised up. Is that possible, groundwater recharge in hill country like Nuerelia? Is it the cause earth sliding hill slopes?
Mr. Rajkumar, so I mean, this is a question for a geotechnical engineer. So I'm a civil engineer, so probably I might not be in a good position to answer. So if the person, the gentleman who is asking this, if you can share the contacts, he can put, if he can put an email, I would be able to get you with a very clear explanation. For my gut feeling, the nature has been gone for long years. So the age of the earth is almost, they are calculating like 4.5 billion. So this is nature, whatever that we found, and the settlement, the establishment has gone in that way, the stability is gone in that way. If you go and do, I mean, like excessive storage, there might be some unbalance. So we should not disturb the nature, but still we can think of going with the maximum possible storage. What we find in the recent past in Norelia, so the almost all our water resources have been gone out. So we do have 5 different intakes around Pituthalagala mountain for Norelia Municipal Water Council. I do have experience in last couple of years. So the water availability has been drastically gone out. So that recharge in might that we have to think of first, not that huge storages that we might not be promoting in that area, but still if you can get the possible maximum water availability within the soil structure itself, that probably providing us good living environment. That's what we have to keep in mind.
I think to add to that, what Dr. Veeragoda is saying, it's horses for courses, right? So groundwater recharge is not something you do lightly. And probably it's impossible to answer that question in 2 minutes. So, for example, there are aquifer recharge schemes in Perth, in Australia, and we don't do groundwater recharge in Melbourne. Why? It's not suitable, right? So you do your feasibility studies, you do all your assessments to see whether it is feasible. If it's not feasible, you can't do it. The soil, the soil conditions in Melbourne, it does not suit that. So we don't do groundwater recharge. Whereas in Perth, it is quite suitable. So you can do groundwater recharge in the Adelaide. There's groundwater recharge schemes. So I think it is you need to do the investigation before. Where's the groundwater recharge going to come from? Where's the source? Is it treated wastewater? Is it rainwater or stormwater? And then you do the assessment of the area, or proper assessment involving all the right people.
Thank you, Dr. Perugoda and Ashoka, for answering that common question. Ashoka, there is another question posted to you. What are the actions taken to aware the public to protect the catchment areas?
So I can certainly, I guess, talk about what happens in Melbourne. If you come and visit our catchments, it is legislated, so it's legally enforceable, and also the Water Authority have the full powers to prosecute people. And one way of informing is to the public is through our, I guess, Water Authorities media. But also, if you visit our catchments, you will see very clear signage saying this is a protected catchment, right? So in areas where it's not protected, we work with the community. For example, there's about 20% of our water that comes from the Yarra River, similar to what you saw in the in your introductory slides, Mr. Rajkumar. Top end of the catchment's pristine, but as you go down the river with developments, it's not pristine. So we work with the community. For example, we have a backlog scheme to replace or get rid of septic tanks using a properly designed and constructed sewerage system. But also we communicate, there are 4 water authorities in Melbourne. We have, marketing and communication people working with the community all the time, not just catchment, but also everything to do with water supply.
Thank you, Ashoka. Well, there's another question also being posted to you. Development activities increase the catchment encroachment. How it can be minimized by proper urban planning?
Yeah, I think that's a good question. Probably in the Sri Lankan context, I don't think I can answer. Obviously, my understanding, I'll talk about the Sri Lankan context first, but I think that is important to you. My understanding with my involvement in water safety plans is you do have, I guess, legislation to protect the rivers and the riparian areas, but how do you enforce that is another question. If you, I guess, take the case of Melbourne, yeah, so we do have very clear processes in place to do that.
Thank you, Ashoka. I think we will come to the last question. I think this will be posted to Dr. Verugoda. And I think thanks for the very catching presentation by both of you. And Dr. Verugoda, as engineers, did we try to analyze and estimate the loss to the economy due to aggravate effect of climate change?
Yeah, so that's something that if we can put up in with financial figures, probably we would understand better. So that is what the past records in Sri Lankan context. So we are getting a very good example from the agriculture sector itself. So as I said previously, also 1 billion of US dollars equivalent product being lost in last decade due to climate change, especially due to drought. So that is the question that we have to think of. I mean, that is the situation. So whenever you take the whole, the loss might be much more than that. So that's really alarming. So that is what I do have in my fingers right now, Mr. Rajkumar. So I mean, like, very good example. If you just take the all economical loss, like during after having this long dry spells as well as floods, so that's devastating. So that's question might bring up some simple example, like the last 2012 flood in Bangkok itself, they lost 685 billion baht worth property. That is within a couple of days of time. So huge money is coming. So that's almost equivalent to 1.5 trillion rupees. So that's how that this damage is coming. So that's something we have to keep in mind. So all the way. So planning again back, preparedness again back is something so serious for us to think of. That is what I can bring up here, Mr. Rajkumar.
Thank you very much for the presentation and giving lucid answers for the questions that were raised across. I think it was an excellent job on your part, and I will hand over it to the company again for to continue with the balance of the program. Thank you. To Sridharan, over to you, please.
Thank you, Engineer Rajkumar. Now we have come. It's time for delivering the token of appreciation to our guests who have dedicated their time and effort to share their knowledge and experience with the participants in this evening. And since we are meeting virtually, first we will see the token of appreciation to Engineer Asoka Jarat. Moving on to the memento to Dr. Veragoda. Both will be sent to them physically via Sasidan.
Thank you so much.
Thank you. Now we have reached to the end of today's session, and it's almost 7:20 now. Now I would like Engineer Hapu Arachi, former Additional General Manager of National Water Supply and Drainage Board and Executive Committee member of Water Forum to deliver vote of thanks. Over to you.
Thank you. I am pleased to propose vote of thanks, concluding this interesting and interacting session. On behalf of Water Forum of IESL, we are extremely thankful to our two resource personnel, Engineer Asoka Jayaratne and Dr. Veragoda, for accepting our invitation and making these useful presentations and clarifying so many queries raised by our participants. We also extend our sincere appreciations to all of you for your active participation, making the event a success. A big thank is also due to ISL staff led by CEO Engineer Neil Abhisekara for all the assistances extended by you all. Particularly, we should mention IT team. Your contribution made this virtual program a real success. May I take this opportunity to extend our appreciations to Mrs. Bhadra Kamaladasa, our chairperson, Water Forum, for your guidance, and Tilini, though she is not here, our secretary, Water Forum, for your total contribution, and Mr. Shasidaran for your voluntary active participation and contributions, Engineers Nalayan and Sridharan for comparing the session, and all the members of the subcommittee under the leadership of our friend Engineer Rajkumar for giving valuable ideas and contributions to make this event a successful one. There are so many others who have not mentioned by name, but our thanks should go to all of you. Thank you very much and good night to all.